Madhuri will come in 5 minutes. Huh?
Yeah.
She's here. Hi, Madhuri.
Hello.
Hey, your voice is
Good morning.
loud today. How come you are loud today? Gone again. Madhuri, did you extract this file?
Which one?
Virtual machine?
Mm, yeah.
It is working for you?
I'm just saying I've not installed anything.
Very good. Okay, just 2 minutes this will happen. Mangesh, you just check on, then we will continue.
Okay. Yeah.
Actually, there is some problem in the download that happened. Maybe while uploading or downloading, something got corrupt.
Okay.
No, I'm telling this to Madhuri. Yeah, that's why Mangesh was trying it yesterday, so he was finding it difficult, getting some error. So he has somehow figured out which file was corrupt. How did you figure that out? That is the direct error that you were getting, right?
Yeah. So that file didn't extract it.
Okay. So out of 11, you have 10.
Yeah. So on this virtual machine, we don't have to install anything, right? We just need to see the configuration and verify with those commands.
And you have to configure it.
Configure in the sense
See, Hadoop is
creating
already installed. Hadoop is already installed into it. You just have to
yeah.
configure your services.
Okay. Okay. No need to create the folders, right?
You have to create the folders and everything. That lab that we did, that is the complete
Mm-hmm.
configuration of your services. Of first formatting your name node, then starting your HDFS services, then creating your MapReduce specific directories, then starting your MapReduce services, then running a sample program.
Mm-hmm.
That is a part of the configuration. See, installing Hadoop is just one simple command of yum install.
Okay.
If you will check the videos that are present on the in the course Introduction to Big Data Hadoop,
Okay. Okay.
you will come to know how we have installed this CentOS ka image. Then you'll come to know how we have installed Hadoop. Then how we have installed Java, MySQL, everything.
So Hadoop configuration document, we need to follow that.
Yes, you just need to follow the Hadoop configuration ka document. Baki backend work is everything is done.
Okay. Okay.
No, 406 MB. My God, that's why it is taking so much time.
So we can start.
Yeah, we can start. We'll start. We'll start. Just a second. Hmm. So it'll happen in some time here. Then we can get back to this. Okay. So today's agenda is talking about Scoop and Hive. What is Scoop?
There's an ecosystem for import-export functions.
Between
Importing the data from other servers.
other servers like
RDBMS to export this.
right. So Scoop is an import-export tool between RDBMS and HDFS. Okay. So what you can do is talking about import and export. You can import all tables from RDBMS, or you can import few tables from RDBMS, or you can import a single table from RDBMS, or you can also import So you can import all tables from RDBMS, or you can import few tables from RDBMS, or you can import a single table from RDBMS, or you can import the result set of a query from RDBMS. Means you will specify a query in the command, that query will run on the RDBMS, and whatever the result is, only that would be imported. And for export, you can import a single table or all tables. Okay, so this is what Scoop can do. Okay, so I'll tell you about what is this delimited files when we start doing it actually. Okay, anyways, what is this delimited?
This is a kind of a character which can be introduced in between the data files in order to manage the data in a particular fashion.
Exactly. Delimited files is basically a type of text file, okay, in which we know that every word would be separated by some delimiter. Every word would be separated by some delimiter like a space or a tab or a slash or a comma or a pipe. Okay, a delimiter means it can be a slash, it can be a comma, it can be a space, it can be a tab, it can be anything like which can separate two words. Okay, and a delimited file means it is always an assumption that it is having a delimiter and the end of a record or a end of a line is marked by a new line character. So this is my new line character. It is shifting to a new line. This is a delimited file. So if you have a delimited file in your HDFS, then you can import that to your RDBMS. Clear?
Yeah.
Okay. Just a second. Sorry. So talking more in detail about Scoop, your Scoop uses JDBC for connection and communication with RDBMS. What is JDBC?
Java database connector.
Right, it is Java Database Connector. So this is a protocol. This is a protocol which is used by the RDBMS to communicate with each other or communicate with a third party external tool. Okay, this is a protocol used by RDBMS. For communicating with any other RDBMS or any third party external tool. And hence your Scoop can communicate with any RDBMS. Even Scoop uses JDBC for connection and communication. Even RDBMS use JDBC for connection and communication externally, and that's why your Scoop can communicate with any RDBMS. Clear? So Scoop is nothing but an import-export tool between HDFS and RDBMS, which can import all tables from RDBMS, few tables, single table, or result set of a query from RDBMS. It can export the delimited files as tables to RDBMS, Because Scoop and RDBMSs use JDBC for connection, that's why Scoop can communicate with any RDBMS. Okay, and as all other ecosystem tools, Scoop is also installed on a client, and the backend of Scoop is also the same working principle of MapReduce as for any other ecosystem tool. So now if we try to see the working of Scoop, then it goes something like this. Yet again I have my client. In this, when I install Scoop, I can start writing the commands of Scoop from the command terminal itself. You don't have a separate shell for Scoop. You don't have a separate shell for Scoop, but you can make use of the same command terminal of Linux. So I'll just write Scoop shell, not Scoop shell. I'll write Scoop terminal. Okay. Scoop does not have its own explicit terminal or its own explicit shell. It makes use of the same Linux ka shell for issuing its commands. Okay. Then as any other ecosystem tool, even this guy has two things. One is your query engine and one is your library. And inside your query engine, you have your compiler. And you have your processor. And inside this, you have a number of MapReduce programs. Now, what you have on the other end is you have a Hadoop ka cluster in which you have your name node. And data nodes. Apart from this, what you have here is ARDBMS. Now this RDBMS this RDBMS has a JDBC connection protocol called port open. Okay, and this is the port for communication with your Hadoop cluster. Okay, now, okay, before we proceed, uh, what is a data node? What is a data node? Very good. Very good. What is a data node, guys?
It will do the processing on the slave servers.
Sorry?
It is it is a service which will do the data processing on slave servers.
Perfect. See, this is the way to go, right? Recently, I conducted a interview drive on this Saturday. Last Saturday, which went, I conducted an interview drive in which I rejected almost 8 people by making them cry on only this particular question. What is data node? Or what is name node? Or what is job tracker? Or what is anything like this? That when I asked them what is a data node, what they were saying is data node does this. The data node handles storage, or data node is the slave, so it will work along with the name node. Or some people even sat there explaining me the entire job process. Okay, but that is not what the question is. The question is, what is a data node? So data node is a simple Hadoop ka service or a Hadoop ka daemon or a Hadoop ka process that takes care of the storage or HDFS at the slave level. Okay. Now tell me, what is a task tracker?
Processing daemon.
Sorry?
Processing daemon
Right.
service.
So task tracker is the slave processing daemon or MapReduce ka slave daemon. Right? Okay. Now tell me, when your job tracker does the allocation of a task to a task tracker, when your job tracker does allocation of a task to a task tracker, what are the different criteria that it takes into consideration?
The data node should be up and running.
Mm-hmm.
Then the data blocks should be available on that slave server.
Mm-hmm.
And execution
Execution.
execution slot, I guess.
Right. So first of all, your data node and task. Exactly. The execution slots should be available. So first of all, your data node and task tracker services should be up and running. right? Then
Yeah.
secondly, the data block should be available on that particular data node, right? And then your task tracker should have empty or free execution slots, right? So when we talk about execution slots, so there would be like, let's say if there are 10 execution slots in a task tracker or for a task tracker, it means that it can execute 10 commands or 10 tasks simultaneously, right?
Yeah.
Okay. So if I am saying that my program requires two map and one reduce task, or my program involves two map or one reduce task, does it mean that I should be having, or if I say that my program requires two mappers and one reducer, does it mean that I require three task trackers?
No, probably the mappers can be the from same node.
And reducer?
Reducers. That's what I mean. The statement is false.
Right. So if I am saying that I need two mappers and one reducer in my program, it means that I want to execute the map function twice and reduce function once. So if a single node can do it, then well and good. If two nodes can do it, well and good. If three can do it, well and good. Clear?
Yeah.
Okay. So we'll need this.
Jayant, one question related to this discussion.
Mm-hmm.
Is it possible to fire multiple jobs from a same client simultaneously?
Sorry. Yeah. What? Multiple jobs from the same client.
Yeah,
It is possible. It is possible, but you'll have to do it from different terminals.
different clients, you mean to say?
Not exactly client, same client, but different instances.
Okay, okay, yeah, got it.
Different instances of your same client.
Okay.
Okay, so now, see, this is very important to understand. All your commands in Hadoop, all your commands in Hadoop, if you have observed them nicely, whatever commands we executed so far, okay, what do all commands consist of? They consist of service that we would be running, or the service that we would be using for executing any operation, right? Then if at all type is required, then type of file or type of file system, right? Then we have your actual command, and then we have some parameters, right? This is how your any sample job will look, command will look like, job will look like. So now what we have is in scoop, we have the service that would be executing it. Let's say we have a command as import. So this is the command. Scoop is the service, import is the command. Then as a part of parameters, what I would be specifying is the first option of connect. The first option would be connect for me. Which will specify the protocol to be used. Then it will specify the type of database which is going to be to which we are connecting. Then sorry. Then the IP address of the server to which we have to connect, or IP address of the server to which this is located. So this one. So let's say this is located on 192.168.1.200. So here we'll say 192.168.1.200, and then name of the schema or name of the default database inside your server. So let's say we have it as so far it is clear what is this. It is having the name of the protocol to be used for connection, name of the server to which your type of the server to which you're getting connected, IP address of the server where the MySQL is running, then the default database or default schema under your server. Now I am saying that default database or default schema because if you talk about Oracle, then it is default schema. If you talk about MySQL or PostgreSQL, it is default database. So it has different terminologies and different kind of architectures that these databases hold. Clear?
Yeah, Jayant, one question here.
Yeah.
Is it mandatory to use default database or can I use the required database name as well?
You can use the required database name as well.
And what about the IP address? Can we use the machine name?
Host name you can use, yes.
Okay.
You can use the host name as well. Okay. So this is a very simple sample, not simple, but yes, this is a very default or basic map scoop ka command in which we assume that the table that we have to import is there present in the default database itself. Because if you want to do a generalized query of like listing all the databases in your MySQL ka server, then this is the query that you would be using. Only instead of import, it would be list databases. So at that time, you will just say that, okay, I need to connect to a server in which the default schema or default database is this. And then list all the databases inside that server. So that's why I've written default database here. And talking about port number, yes, it can be your host name as well. And when we would be doing the practical, we would be using host name because it is localhost or local domain for us. Clear? Okay.
Yeah.
So now what we have to do is this is one of the parameters. Then the second parameter here would be the name of your table. If you do not specify the name of a table here, then the import will get to import all the tables. If you do not specify a name of the table here, then import will import all the tables. If you specify comma separated tables here, then import will import all the comma separated tables. If you specify a query here, the import with this command will execute a query on the database and will fetch only the result. So here we are saying that I have a table called as test table and I want to import that. Then you would be specifying the username. Again, this is optional parameters. So it is root, let's say, and then you would be giving the password, which is again root, let's say. Okay. So far it is clear.
Yeah. Yeah.
Okay. Then you would be specifying one more thing in here saying the fields when you will import it, you have to dump it inside your HDFS, right? So you will have to create a text file out of it, right? Because your HDFS finally supports or stores everything as a text file. So if you want to store anything from anywhere, from a JSON or a C-based interface of the database, then you'll have to first convert it into a text file and then you'll have to dump it. And whenever you talk about a text file, you should have something that will separate it. So we'll say the fields would be terminated by anything, let's say a tab. So this is the delimiter that is used and we are specifying it here that this is the delimiter that is used. This is clear that the fields would be terminated by /t means what? This is the delimiter that has to be used while importing and converting it into text file. So whatever table you have, that table would be converted into a text file which would be delimited and separated by tab. So let's say you have it like this: ID, name, salary. One ABC 1000, two PQR 1500. So when this will get converted in a text file, it will look something like this: one tab ABC, tab 1000, then two tab PQR tab 1500. Now please note one thing here, this will be very useful when working with Hive or while exporting or working with Scoop Export, that tab is different and space is different. Tab is different and space is different. Please do not do this that you are mentioning the delimiter as tab and you're using the separator as spaces, because that won't work. So finally, this is what is expected, that this is a table which is present inside my RDBMS. and it needs to be dumped in my HDFS. Okay, now tell me this, if this file is 110 MB, okay, if the size of this file is 110 MB, with all default parameters set, how many data nodes will I require ideally to store this file? The file size is 110 MB. Provided all the default parameters are set, ideally, how many data nodes would I require to store this file in my HDFS?
So logic, so ideally one.
One?
Yeah.
How? How one?
You're asking data nodes, you're not asking blocks.
Yeah. So I'm asking
So
ideally
data,
how many data nodes would I require? Ideally.
yeah, two.
How
It
come
should be
two?
two.
How come two?
One master and one slave.
Master does not store data node, right? Master will not
Yeah,
store the block, right?
but it will be counted as a node.
No,
So
no,
in a
I'm asking data node.
cluster,
I'm asking how many data nodes ideally would I need if my file size is 110 MB and all default parameters are set.
it's only one.
How?
So one data node is sufficient enough to manage that sized file.
How many blocks would be there?
There will be two blocks, and if we consider the replica, then total 6 blocks.
6?
Yeah.
Right. So 6 blocks. So ideally, I'll require 6 data nodes. Every block, every chunk would be distributed ideally to a different data node, right? If provided we are working in a distributed environment. Right?
Yeah, but
Yeah, come on.
okay.
Tell me. See, this is an actually interview question.
Yeah, I mean, single data node, there is no limitation of how many blocks. If we consider the redundancy kind of thing, we are already having a name node and secondary name node. So no need to have a redundancy for data.
Oh,
So
no. You need to have redundancy for data. We have done that failure handling wala thing, right? Node level and task level failure.
yes,
So your name node is a part who will maintain only the mapping. Your name node doesn't have data.
right.
So name
But
node
it,
is
it stores the mapping definitions.
exactly. But if you don't have redundancy in your data nodes, then if one of the data node which is having the data, it goes down, then the data is lost. So no use of having
Right.
mapping. See, I am saying
Okay.
that, see, why I was stressing on the word ideally, because if I have a book of Hadoop which can be broken into two parts, Hadoop admin and Hadoop developer, but I don't break
Mhm.
it. I give it completely to Mangesh. Then if Mangesh doesn't show up, then I don't have the copy of that book, right?
Okay. Yeah.
Secondly, I can simply give the book Hadoop as one single book to Mangesh, replicate it, and give it to Madhuri. Still, I have a failure recovery. That if Mangesh
Mhm.
doesn't come in, I have Madhuri to help me out with the book, right? But in
Okay.
that way, if something is to be done on the Hadoop book, if something is to be performed on the Hadoop book, only either Mangesh can perform it or Madhuri can perform it. So I won't have the parallel processing involved. That's why what I
Mhm.
do is, first of all, to achieve parallel processing, I split the file into two blocks, admin and developer. Then to achieve failure recovery, I replicate it.
Okay.
So in an ideal scenario, if one file can be split into two blocks, then in an ideal scenario, I require 6 different data nodes to store it.
Right.
In an ideal scenario, yes, you can go in a pseudo distributed mode wherein you will have only one cluster, one data node, wherein every block and everything would be there. But if you again talk ideally, then a data node, a pseudo distributed Hadoop cluster के अंदर, ideally you won't have a file size which can be greater than 64 MB. Ideally, because a pseudo
Mhm.
distributed mode is always used for test purpose or learning purpose. So you won't have a file ideally in a pseudo distributed mode which would be more than 64 MB. Secondly, ideally as well as default configurations for a pseudo mode says that the replication factor is only one, means only one copy would be there. Okay. And again, ideally, when you talk about a Hadoop cluster, it is always a distributed Hadoop cluster. As long as it is not specified that you are working in a pseudo distributed environment for which Hadoop was never meant. If it is not specified that you are working a pseudo Hadoop ka cluster, working in a pseudo Hadoop ka cluster, then you should not consider that you are working in a pseudo Hadoop ka cluster, because pseudo mode is not something for which Hadoop was meant. Because if you talk about pseudo mode, it is more or less like a vertical scaling. And we were already fed up of vertical scaling long back, and we have already moved into distributed scaling, horizontal scaling. So ideally, whenever you talk about a Hadoop cluster, it is always in a distributed mode. Ideally, whenever you talk about a Hadoop cluster, the default configurations always say that it is replication factor of 3. Ideally, when you talk about a Hadoop cluster, every file would be split into blocks of 64 MB each, and all the blocks would be replicated, and all these chunks would be distributed across different data nodes. Because this is what care is taken by your name node while creating a mapping, that no two blocks of the same or no two copies of the same block reside in the same server ideally. See, there are always two different approaches that you have. One is a real approach and one is an ideal approach. Ideal approach is always different from the real approach. But when we talk in theoretical terms, or when you have to answer it in theoretical terms, you have to answer it ideally. So if an interviewer asks you this question, that ideally, how many data nodes will I require if I have a file of size 110 MB? Then you have to answer that ideally we would require 6 data nodes. Then you may clarify yourself saying that provided your application factor is 3 and provided that you're working in a distributed mode of Hadoop cluster.
Okay.
Clear? See, whenever
Yeah.
the interviewer will ask you a question, try to first answer him on what his question is sticking around. if his question is informative enough for you to understand each and every parameter clearly, that if the interviewer is asking you a question very clearly saying ki the replication factor is 2. See, whenever you talk about file storage, right? Whenever you talk about a file storage, what should be the parameters that should be discussed? First one, the block size. Second one, the number of the replication factor, value of replication factor. Third one, the number of data nodes available, right? Or
Right.
I'll say the number of up data nodes or live data nodes available. And fourth one, not necessary, but still the type of cluster, pseudo or distributed. So if you're already specifying the number of data nodes, then pseudo or distributed is no point. Because if it is one data node, then you can obviously come to know that, okay, it is a pseudo mode. If you have more than one, then you'll obviously come to know that it is not a pseudo mode, it is a distributed mode. So these are the three parameters that need to be discussed whenever talking about file storage. And in that
Yeah.
sense, if the interviewer is not mentioning anything about this, or if the question is not specifying or clarifying anything out of this, then you have to consider the default parameters that the file size would be either 64 MB or 128 MB, which is the default, 64 MB being the base ideal default. Okay. Then you have to consider that it is a replication factor of 3, and you have to consider that unique data nodes are available to you as much as you want.
Okay.
Clear?
Yeah. Sure.
Okay. Now you're also clear with why we are why we are splitting the file into blocks so that we achieve parallel processing.
Yeah.
Okay. So this is what we have to do from using a scoop, that your table is present inside RDBMS. You have to convert it into a text file and you have to dump it in HDFS. While getting dumped inside the HDFS, it will always go through the file anatomy of write, wherein it would be first split in blocks of 64 MB each, and then it would be replicated and blah 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 blah, and then it would be finally distributed after the mapping is created onto your data nodes.
Jayant,
Yeah.
when you're converting your table into a file, delimited file,
Mhm.
do you require the table headers like ID, name, and salary?
I was waiting for this question. Okay. So when you're converting your table from a text file to this thing, or basically talking about this import specifically, when you're importing a table to a HDFS, then your headers don't come into picture.
What in case we are having selected fields?
In case you have having selected fields, then you can give the option of having a header into place. Okay. But still, header is not important because when you would be using this file, you will anyways have to specify what each of the row means to you, or what each of the column specifically, not row, sorry, what each of the column means to you. So here, when you look at a text file, I can name the first column as number, I can name the second column as text, and I can name the third column as a relation between the first and second column. This is what I will find out of the text file that I have while actually working onto it. See, Scoop is not bothered of what you do after the data is dumped inside HDFS. Scoop is not bothered about what you do once the data is dumped inside HDFS. That is a completely new logic that will come into place, or a completely new set of transformations, or completely new set of actions that would come into place once the file is dumped inside the HDFS. So what you do after that, the Scoop is really not bothered about it. So it will not give you the parameters. It will not give you the headers. So when you will work on the file, then you'll have to give the headers. Even while importing the query, it will not bother about giving you the headers. You can still do configurations and make it give headers as well, but that is not even recommended.
Okay. Uh, are you going to have a practical session on this scoop execution?
Yeah, of course. Yeah.
Okay.
Yeah,
Okay.
we would be
So
having a
there are certain questions. Yeah,
sorry.
there are certain questions in my mind right now
Yeah.
because I'm not sure how this storing the data on HDFS file and storing the exporting back to the RDBMS server that I want to get clarified.
Exporting back, right?
Yeah.
Okay. See, it is actually not exporting back. It is just exporting. First thing, it is not
Yeah.
exporting back. It is just exporting. So if it is why I am saying that it is not exporting back, it is if it is exporting back, then you will kind of get a hint that you have imported, then made some changes, and then now you are exporting it. That is what you can be said as exporting back, right? But that is not the case. We are not going to modify the file. You cannot modify the file which is present in HDFS. Now let's say the file that you can right now see there, which has one ABC 1000, two PQR 1500. Now if you want to export that inside your RDBMS, then now what you require is inside RDBMS, you should have a blank table created which will have three columns with the same data type that this file is telling you about. So no matter what column names you're specifying, but the column data type should always be first, not always, like if this is the file, then it should be first is the int, second is the string, and third is the int. No matter what data types or no matter what column names you're giving inside the RDBMS, but it should always comprise of three columns, wherein the first column would be of data type int, second would be of data type string, third would be of data type int again. And then you would be exporting it from your HDFS, saying that dump it in that particular location. You would be having labs on this. You would be having assignments on this rather. Lab would be one lab wherein we would be using a default import ka command and importing data from Scoop to HDFS. And the lab will continue to the second part wherein you would create a table in Hive using that data which you just imported from the RDBMS, and then you would be querying that. This would be your lab. But there are assignments, there are advanced lab sessions, not sessions, manuals, which you have to do as homework, okay, in which you will have all this stuff included, which is importing all tables, importing few tables, importing selected tables, and exporting data tables into RDBMS. All this would be covered.
Okay.
So as we have created that the HDFS file, text file. So while I am exporting this to RDBMS,
Hmm.
as you have created a table and table as ID, manager and employee
Hmm.
employees.
Hmm.
So the same data will be exported to that table, right?
No, if you have created a manager and if you have given a data type of string, so if you
Yeah.
have created
And
a table as,
employees as an integer.
sorry,
Employees
again as
count
a
as
string,
an
right?
integer. As an integer.
Okay, so you have integer, string, integer.
Yeah.
Okay. Then
Then the same data will exported here.
same data means,
Means the previously I have this table, right? ID, name and salary.
uh-huh.
From there I have imported the data
Mm-hmm.
to HDFS.
Okay.
From HDFS I am exporting the data to the RDBMS table as ID as an integer, employee manager as a string and employees as an integer.
Okay.
So will it be exported in that table, right?
Okay.
Is it right?
Yeah, it would be. It would be exported. No, but I didn't get the question. Means I didn't get the doubt behind the question.
No, I was just confirming if the process was right or
No, 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 no. The process is not like you are importing. See, that's what I'm saying. It is not export back. It is not that you would always be importing a table and exporting it again. Why would you do that? Why would you
Then
import the same table and export it back? Why?
no, no. Probably her question is, suppose I am having this integer string and integer data type, and
Uh,
if I am exporting with integer string and string, whether that will be an successful execution or not.
no, that would be an error. That would throw an error saying ki the data types don't match or the definitions don't match. No, but she specifically said that it is ID, string, and ID. Sorry, integer, string, and integer. So in that case, it will get exported. But why would you do that? So you already have, see, while importing, the data is not deleted from the RDBMS. So
yeah.
this table, even after import, still remains in your RDBMS as well.
Yes.
Importing is always migration, copy to copy from. Importing is never cut paste.
Yeah.
Importing is always migration, copy to copy from. It is never cut paste. So if you are already having the data there, why would you again export it into the RDBMS? First thing, you won't do that. Second thing, even if you want to do it, you can do it, because this would be, let's say, table basic employee. That would be, let's say, basic employee 2. So that's okay. Madhuri, have I got your query correctly?
Yeah.
Okay. So you can, but you won't do it. Why would you? That's what I said. No, it is not. When he said exporting back, I made sure to catch it on back that it is not exporting back, because if you say exporting back, means what? You have imported something, you modified it, and now you're exporting it back. But this option is not available to you in HDFS of exporting it back, because you cannot change anything into that. Possibly you can create a table in Hive, make changes to that table, which will create another table, which you can store as a text file, and then that text file you can possibly put it in there. Like for example, I have to add 100 rupees to each of these employees. Then I'll have to do it in a query. Then I'll have to store that result of the query as a table in a text file inside HDFS, and then take that text file ka data and export it to your RDBMS. So that you will do. Clear? Clear, 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 clear.
Yeah, clear.
Okay. So again, fields terminated by /t, then username is root and password is root. Now, there is one more option that is important that we would be specifying, saying m is 1. Okay, saying m is 1. This particular, this thing, what you call, option, this particular option is mostly used when you are dealing with, a single pseudo node cluster or some special type of tables. Okay, we'll talk about that in detail, but this particular command means that you are using only one mapper. So I'll not put this initially, forget it. So this is a command, forget that M1, I'll explain it. Okay, so this is your command. So now what will happen is, I'm deleting this. So we are not going to see this backend process in so much detail for other tools, huh? Because we know that everything is same. Just because this is the first tool that we are doing, so we are looking at into so much details. Okay, so this is your command. This command is something that you would be writing inside the scoop ka terminal, means the same Linux ka terminal from where you can talk to your scoop. Okay, this command you would be writing in this. Now this command of yours will go to your compiler. Which will give it to, let's say, the processor, where it would be broken up into two parts. One would be the command and the other would be the arguments. Okay, so if you peep in here, then your command is only this much: scoop import, and rest of all are your arguments. Okay, the command is only this much, rest of all is your arguments. So this is how it is splitting the command. It is command and it is arguments. Okay, then the processor will rush into your library and fetch out a jar file. Okay, it will run into the library and fetch out, let's say, this jar file of yours. I'll call it as import.jar. Okay, I'll call this as import.jar. Now from the arguments, now this arguments would be given to this guy, import.jar. Okay, now from the arguments, this guy will come to know where is the database located. It will also come to know which table is to be imported. It is also come to know how to create a text file out of it, and the username and password of the database, or of for logging onto the database. All this he will come to know from the argument. Okay, now if you talk about this jar file, then this is a map reduce ka jar file, right? So normally it should be having three classes: map class, reduce class, and main class. Okay, But what this will have is only two class. One is your map and second is your main class. Why it does not have a reduce class? Why
Because the data processing doesn't require it.
means you're correct, but can
It's-
you
We are not
elaborate? Yeah,
Yeah, we are not using any arithmetical or some
e-
combiners or related operations.
exactly. You don't have to aggregate the data in any sense. You have to copy it as it is, do not apply any transformations onto it, and dump it inside your HDFS. So if there are no transformations to be applied, then there is no need of getting a reducer into place. If there are no transformations to be applied, then there is no need of getting a reducer into place. Okay, so this is one property of this default import ka program, that it is only a map class wala program. It is a only mapper map reduce program. It can be also called as only mapper map reduce program. Only mapper map reduce program with default 4 mappers. And this is the reason why I took you to all the revision of your cluster and your services, that this is a default program having only mapper program with 4 mappers. Means what? Your map function should be executed 4 times. Your map function should be executed 4 times. Now this will then go and communicate on the port. This will go and communicate on the port, wherein first this will go to the job tracker. It will tell the job tracker that, okay, dude, this is my database and I need to bring my files from here and dump it inside. I need to bring some data and dump it inside your HDFS. Now, dude, you tell me, how are you going to work with it? Give me some destinations. So the job tracker will say that, okay, don't worry. It will go to the name node. It will tell the name node that, okay, I need 4 destinations. Then the name node will say that, okay, you can take data node 1, data node 2, data node 3, and data node 4. Okay. First part of whatever you're getting, dump it inside data node 1. Second part under data node 2. Third part under data node 3, and fourth part under data node 4. Then the job tracker will go there and the job tracker will initiate his task trackers onto it, saying that task tracker 1 will execute first time map function, task tracker 2 will execute second map function, task tracker 3 will execute third map function, task tracker 4 will execute fourth map function. Now in this fourth time the map function, not fourth map function, fourth time the map function. Now the execution of every map function will connect to the RDBMS and fetch 25% of the data and dump it inside your HDFS. So I'll just show the connections between the data node itself. Okay. So it is like every task tracker is getting connected. So every task tracker will establish a connection with the RDBMS, run a map function, which will fetch 25% of the data, and it would be dumped inside its data node. So when the 25% data is coming, again, all the blah blah will happen, and you will get it on your HDFS cluster. Okay, and in this way, all your 100% data would be dumped inside your HDFS, and this is a default case. This is clear? Is this clear? What will happen? A jar file will get executed. This jar file will consist of only map class and a main class by default. Its main class is but obvious. It will consist of only mapper. Okay, and by default, how many mappers are required? By default, 4 mappers are required. So once this jar file is getting executed, it will go and connect on the port of the Hadoop cluster, wherein it will interact with the job tracker, saying that, okay, dude, I need 4 destinations from your side. Then it will go, the job tracker will go and communicate with the name node, fetch the available data nodes. Then it will check the availability of his job trackers on those data nodes. Then it will assign task to his job trackers, task trackers, saying that, okay, go and fetch 25% data. Then every task tracker will establish a connection with the RDBMS. Then it will, after establishing the connection, execute the map function on the RDBMS. Executing the map function or the RDBMS typically would mean executing a query. Even if it is importing one table, then it should still be select star from that table. Okay, so importing a query on RDBMS, and whatever the result is, fetching that and putting it inside your HDFS. Same thing would be done by the second task tracker, third task tracker, as well as the fourth task tracker. And in accordance, they would together bring 100% of the data and get it dumped in the HDFS. This is clear?
Yeah, this is clear. Query on import.
Sorry?
I have a query.
Yeah, please.
What in case I want to import conditional data? Like we have this select case wherein we can have the where clause. Is it possible to import conditional data?
It is possible to import conditional data, but in that case, you will be firing a query, and whatever the result of the query comes into picture, that you would be importing. Means select star from employees wherein salary is greater than 100.
Yes, so that query should be available on the RDBMS side. It is not possible to fire a query from the client node, right?
You will fire the query from the Sqoop client itself, but that query should fetch a result and it should be executable on the RDBMS. See, even that import wala what we have said, okay, even the import wala what we have said, simplicity, or in a very simple way, that import, what it is going to do, or the map function which is there internally designed in the import wala command, this jar file, what it is typically going to do is, it is going to go and fire a query on the database saying select star from employees, whatever the table name is, limit from to this. So if it is our first execution, then 1 to 25, second execution, then 26 to 50, third execution, then 51 to 75, and fourth execution, then 76 to 100. Okay, so this is what it is going to do. It is going to fire a query. Now, whatever the query is getting fired on the RDBMS, if it is an executable one, if it can fetch a result out of it, then you will get a result and you can dump that result and it will get dumped in your HDFS. So no matter what query you're specifying from the command, specify any query you want, but that query should be executable on the database. That is the only criteria, or that is the only limitation about the queries that can be used in import Sqoop, that query should be executable on the database.
Yeah, right. But we are not specifying those query statement on our client node, right?
You are, you are,
On
you are,
client, we are,
you are.
on client, we are just saying import.
This is a
That's the
simple
only
command.
keyword we are.
No, no, no. This is a simple command. I just give you an example command. You would be working with selective commands as well. But
Okay.
this is the place where you are specified. I said right that this is a place where you have specified a table. If you do not specify it, then it will import all the tables. If you specify comma separated tables here, then it will fetch those comma separated tables. If you specify a query instead of table, you give an option of query.
When you say query, that query should be available on the RDBMS or the query can be written here. Oh, got it.
Got it?
Yeah. So that can be possible to use nested query as well.
Anything which can be executed on the database and can fetch result.
Okay, got it.
Okay. Now while importing, it will dump everything into a output folder, means it would basically be output folder, right? Like we were specifying a name earlier where the result should be stored for the operation. So here Hadoop will internally create a folder with the same name that of the table. It will create the same name, same folder with the same name as that of the table that is getting imported. So let's say if the query was of even where or anything, but there would be a table name. So if the table name is employee, then in HDFS a tab folder would be created called as employee, in which the data would be loaded. Clear?
Yeah, clear.
Okay. Now let's see the different flavors of scoop import. So as we have seen, it can do all tables, nothing much into it. So all tables means then this is what is really important to understand. Or not this, basically it works for both of those. Okay, so I'll say okay, forget. Then see if you're using your default command, if you're using your default commands, then what it expects? It expects four mappers, right? It expects four mappers. It expects that the data will be split into four sections. Data, to be very precise, in RDBMS is or can be split into four sections. These are the assumptions. The specification is that it will have four mappers. Then the assumption is that the data in RDBMS can be split into four sections. Now for this, what is compulsory? That it should have a primary key, because if there is no primary key, then how can you separate the data into 25, 25, 25, 25%? So there should be a primary key out of which you will decide, ki, okay, this is the total number of records that I have, and then 25 means this many records, 25 means these many records, and 25 means these many records, right? So you should either have a primary key, or you should specify a column name that can be used as a splitter. So in our case, let's say we are saying that the column employee is a splitter. Sorry, a column ID is not, ID is the primary key. Let's say ID was not there. One more column was there as, let's say, country. One more column was there as, let's say, country. And we are saying that, let's say, country is a splitter. Okay. Then what it will do is it will group all the records based on countries, and then it will divide it into 25, 25, 25%. Clear? Is this clear? Like
Yes.
if let's say you have 6 unique countries. Let's say you have 6 unique countries. Then what it will typically do is, ideally what it will do is, it will group all your data based on the 6 countries, and then it will break this 6 countries into 25%. So if I break this 6 countries into 25%, it is 1.25, something like that, right? So 4 of your chunks will have one country, one country, one country, one country, and 2 of your chunks will share the data of one more country, and the other two will share the data of one remaining country. So it would be 1.1, 1.25 data, means a data of a complete country and 50% data of one country, data of one country and 50% data of another country, data of one country and 50% data of another country, data of one country and 50% data of another country. In this way, your 6 countries would be split across these 4 species. That's why it is compulsory that you either have a primary key, or you have a column which you can specify as split by, or a splitter. Clear?
Clear.
So this is the requirement that holds if you are using a default command. If neither of this can be true, if neither of this can be true, then what you can do is you can make a modification in the program and specify that don't go with the default specification, rather use only one mapper. So whatever the data is, fetch it directly with one map function itself. So the map function will change, and it will, instead of saying fetch 25%, it will say fetch 100%. Why this is not advisable? Because if your data is large, then you will have to keep the SQL server ka link open for this much time. And keeping your SQL ka link open for a long time is not secure. Keeping your SQL ka link open for a long time is not secure. That's why you won't try to get into this kind of a behavior, that use only one mapper. This is good for testing and learning deployments, but not good in production deployments. Clear?
Clear.
Okay. So this was regarding your scoop. Now let's go and execute it. No doubts in Scoop, right?
Let's have practicals.
Okay, so Mangesh, this is done. You can check it.
Okay.
Guys, just a second. Okay, yeah. So let's start. So first of all, if you go to, I've unmuted myself, right? Yeah. So if you go to applications, inside programming, you will find MySQL Workbench. Okay. Now what you have to do is, this is for just understanding. This is not a prerequisite, but yes, what is prerequisite is this, that you start the server at least. For starting the MySQL server, you will say sudo service mysqld. This is the server client, not server client, server service of MySQL, mysqld start. Okay. Now for reference purpose, I can go here and check exactly how my database looks like. So the password is username is root, and the password is also root. Okay, so this is what I have. I have Wisdom DB in this, Training DB in this, and Test DB in this. So if I open this, so I have two files, two tables. One is server log and one is employees. So if I check on the server log, then if I do select star from server log, and if I execute it, so this is what I have. I have two columns. One is country and one is IP address. The countries is Australia, something, 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 and it is. around 50,000 this thing in it. Select count of one. Group by country. Okay, so this is that you have 5 countries into it. Australia having 10,000 records, India having 10,000, New Zealand 10,000, UK 2,000, 10,000, and US having 10,000 records. Okay, and the records is that we have seen. Now what we have to do is we have to import this table from your MySQL to your data HDFS. From your MySQL to your HDFS. So first of all, the server is started. So now what we will do is we will check on whether our scoop is working nicely or not. So I'll say scoop list databases connect to JDBC MySQL :/ now it is localhost. See, now you are using the host name and wisdom_db. Then the username is root and the password is also root. Okay, so I gave the name of a database and then it listed all the databases which are present. Information schema and MySQL are the internal databases. We already saw test training_db and this is wisdom_db, which is our database. Clear? So our scoop is working fine. Now what I'll do is I'll use another command and I'll say scoop list tables by connecting to JDBC through JDBC to a MySQL ka server which is located at localhost and the name of the database is wisdom_db. Okay, and again your username is root and your password is root.
Misspell password.
Good, thank you. So you have two tables, employees and server log. So this is clear that so far so good, our scoop is working fine. So now we can go and do our actual operation, which is our import. So we will say scoop import connect using JDBC to a MySQL ka server which is located at localhost, out of which the database that you need to connect to is wisdom_db. You need to bring a table by name server_logs or log. by name server underscore log. Okay, and while bringing it, when you will convert it into text file, please make sure that the fields are terminated by a tab. So it is a tab separated file. Please make sure that it is a tab separated file. Use only one mapper. Use only one mapper because I don't have a split by key column. I don't have a primary key. So use only one mapper. And the username is root. And the password is also root. Service command connection string which says connect via JDBC, the protocol, the type of database server, the location of the database server, and the name of the database. Then table inside this database and how the file would be created or what delimiter should be used. This is what you're specifying here. Either to use a default condition or one mapper, then the username and the password, and then you will execute this. Now, if you see that, very soon your MapReduce program will start running. See, started. Now, if I go to my job browser, so see, you have it here. The name was server underscore log.jar and one map was executed. Now, if I go to then in my browse file system, under my user directory, under wisdom, I'll find a file called as server underscore log in which this is the actual output file and this is your output file. Clear?
Yes, clear.
So this is your basic, very basic scoop import. Okay. Advanced level of scoop labs means the importing it using multiple tables or importing it using a splitter and a primary key wala table. So using it with default arguments and everything and the export and stuff that is there as an assignment to you, in which the lab manual would be shared and you have to do it on your own. So this is the data that we have brought from your MySQL, and if you go and check in the MySQL, the data is still present there as well. So what it has done, it has not done a cut paste, rather it has done a copy paste. And if you can see clearly, a MapReduce program ran at the backend without you writing a single line of MapReduce code. Clear? Any doubts in this?
Yeah, clear.
Okay, Madhuri, clear?
Yeah.
Okay, so yes, we will call it off today. We'll not start Hive and we'll start Hive tomorrow. So you can call it a day, and tomorrow we'll meet the same time and we'll talk about Hive. Okay?
Okay. Yeah.
Okay. Chalo, bye bye. Have a good day. See ya. Bye
You.
bye.
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 Right.
Bye.